Alright, let's go ahead and get started with Lesson 2, Measurements Part 2. This is just a continuation of Lesson 2, Part 1, okay? Alright, so let's first look at the definition of length in general. Just simple definition. Length is the distance of an object. The SI unit of length is the meter, as we talked about in Part 1. Alright, let's look at mass. By definition for this class, we're going to consider mass is a measure of the resistance of an object to a change in its state of motion, or really the amount of material an object has. So we can look at the more material that an object is made up of, the more massive it is. So for instance, a car is made up of quite a bit of material, so it has quite a bit of a mass. But compared to the Earth is much more massive because the Earth is made up of a lot of material. Alright? So that's the way we want to look at mass. Now, as we talked about in Part 1 of this lesson, the SI base unit for mass is the kilogram, which is about 2.2 pounds. Alright? Now, even though the kilogram is the SI base unit, in chemistry, because we deal with very small amounts of material, such as atoms, we're going to use the gram or the milligram. That's going to be our choice of unit for mass in our labs, in our homework tests, and that kind of stuff. Okay. Now, one thing we need to make a clarification of is the difference between mass and weight. All right. Sometimes we use the term mass and weight interchangeably, but they're not the same thing. They are different. Why are they different? Well, mass, or your mass, or a mass of an object does not change. It is constant no matter where you're at in the universe. So your mass on Earth is the same as it would be on the Moon, or on Jupiter, or some far-reach star out in our solar, or out in the universe somewhere. Okay, mass doesn't change. All right. However, weight does, because weight is based on our mass times the gravitational force or pull that is on us. So because gravity, the force of gravity, changes from location to location, therefore our weight is going to change. So for instance, you're going to have a greater weight on the Earth than you would on the Moon. The Moon still has gravity, but the amount of gravitational force on you is not as much as it is on Earth. Alright? So your weight changes, but your mass doesn't. Okay? And that's what I want you to remember. Alright, let's look at volume. Alright? Now, as far as the definition of volume, it basically refers to as the amount of space that is occupied by a substance. Alright? The amount of space something takes up. Alright? So you have mass, your body has mass, which is because you're made up of stuff, but you also have volume because you take up space. Alright? Now, what is the fundamental SI unit of volume? Well, there isn't one. Alright? So we have to derive it. And the way we derive volume is from the unit of length. Alright? Now, in all your math classes, you learned a formula for volume of a cube. You learned that if you take the length times the width times the height of a cube, you would get the object's volume. And that's exactly how we derive the SI value or unit of volume using length. So over here we have a cube. Alright? Let me circle this cube here. Alright? Now, the volume of that cube, we take 1 meter. We're going to say that's the length, and we're going to multiply that by the height, which is 1 meter, and we're going to multiply that by the depth, which is also 1 meter. So a meter times a meter times a meter is a cubic meter, all right? Or 1 cubic meter. So the SI unit for volume becomes the cubic meter, and I need you to know that. All right? Now the cubic meter is really big. That's a big volume. And then again in chemistry, we want to think small. So we don't really use the cubic meter much in chemistry. Instead, the biggest unit that we normally deal with is the cubic decimeter or the liter. Okay? So how do we get a cubic decimeter or a liter? Well, you can think of is you take that cubic meter here that we have, and we divide that cubic meter into 1,000 cubes. All right? And it turns out that one of those cubes, one of them, is a cubic decimeter. So in other words, what we're saying is that to make 1 cubic meter, it takes 1,000 cubic decimeters. All right, to make that cubic decimeter or cubic meter. All right. So just one of those cubes here, which you can see right here, just one of those has the dimensions of a decimeter in length, height, and width. So all we do is take 1 decimeter times 1 decimeter times 1 decimeter, and we get the cubic decimeter. And we find out that a cubic decimeter is equal to 1 liter. And so the cubic decimeter and the liter are interchangeable units of each other. All right? And so those are the units that we use quite a bit. All right? Now, if we take 1 cubic decimeter and we break that cubic decimeter into 1,000 cubes. All right? So again, we take the cubic decimeter, just one of them, and we break it down into 1,000 smaller cubes. And what do you get? You get a cubic centimeter. So we find that 1 cubic decimeter is equal to 1 cubic meter. All right? And 1 cubic meter is equal to a milliliter. All right? So again, here's our cubic decimeter right there. I'm going to erase this so it's a little bit clearer. And so we take 1 centimeter times 1 centimeter times 1 centimeter, and that will give us a cubic centimeter, which is equal to 1 milliliter. All right? So take some time to really think about this concept of volume. If you need to replay this lecture video to grasp this, then do. But this is really important, these relationships, especially to understand that 1 cubic decimeter is equal to 1 liter and 1 cubic centimeter is equal to 1 milliliter. All right? All right, so the last thing we're going to look at is temperature. Okay? Essentially this. Temperature measures how hot and cold an object is. All right? And based on what the temperature is of an object, it tells us the direction in which heat will flow. Heat is always going to flow from the warmer object to a cold object. And that's important to understand throughout chemistry. Again, heat will always flow from a warm object to a cold object. All right? And so if you have two objects that have different temperatures, it tells us really which object is there going to be a transfer of heat to. All right? Now, in chemistry, we use really two scales, temperature scales. we use the Celsius and we use the Kelvin scale. Now, most of you are very familiar with the Celsius scale, but the Kelvin scale, maybe not so much. And yet the Kelvin scale is the most important temperature scale out of all scales there is. Now, there's also the Fahrenheit scale, but we're not even going to touch on that in chemistry, so don't even worry about it. Fahrenheit scale is not really useful in science, so we are going to ignore it. So again, Celsius and Kelvin. Now, the Celsius scale is based on water's freezing and boiling point. So when water freezes, then we call that point 0, or 0 Celsius. When water boils, we give it a value of 100, and we say that water boils at 100 degrees Celsius. And this all takes place at sea level. Now, you really need to know what the Celsius scale is based on. Water's freezing point and boiling point, and what those values are. All right? And just remember, you need to also realize that that is based at sea level. Not here in Utah, where we have a higher elevation. Water boils at a different temperature, lower than 100 C. So it has to be at sea level. All right? Now, what is the Kelvin scale based on? First of all, you got to remember from part 1 that Kelvin is the fundamental SI unit of temperature. All right? The Kelvin scale is based on something a little different. It's based on a value called absolute zero, or which is really equal to minus 273.15 degrees C. What does absolute zero mean? Well, absolute zero is assigned a value of 0 Kelvin. What that means is that when an object has 0 Kelvin, or when it is at absolute zero, the object has no kinetic energy. All right? Now, kinetic energy, by definition, is the energy that allows an object to have motion, moving parts, including the atoms that make up that object. So, if an object has 0 Kelvin, it has 0 motion, including the absence or no motion of atoms whatsoever, or of anything of that object. All right? That's sometimes hard to grasp. We've never reached that temperature. We've never measured something at 0 Kelvin. So it's a theoretical point, but we do believe it exists, and we believe that objects could essentially have no kinetic energy or no motion. All right. So here's a diagram of the 3 scales: the Fahrenheit scale, which again we're not going to even talk about, and then the Celsius scale and the Kelvin scale. Again, the Celsius scale is based on the freezing point of water and the boiling point of water at sea level. And the Kelvin scale is based on absolute zero. So if you want to look at this by relation, at 0 degrees C, it's equivalent to negative 273 Kelvin. All right? That's the deal. And then water, it boils at 100 degrees C, which is equivalent to 373 Kelvin. Okay? Now, because of this relationship, it makes it easy for us to convert from Kelvin to Celsius or from Celsius to Kelvin. And I'm going to show you how that works right here. All right? So the relationship between Kelvin and Celsius is this. To calculate Kelvin using Celsius, you take the Celsius temperature and you just add 273.15 to it. All right? Now, if you forget the 0.15, it's okay. But just remember 273. Always add 273 to Celsius, and that will give you the temperature of the object in Kelvin. All right? You should also be able to take Kelvin and subtract 273 from it, and that will give you Celsius. So you need to make sure that you can convert back and forth between Kelvin and Celsius. I'm going to quiz you on this equation, that you know it. Okay, so memorize it. In time, as we move on in chemistry, you're going to use it a lot more readily. Alright, that's all I have for you for this lecture video. Please study your notes really well. Prepare for a quiz in class over this material. If you need to, relook at the video, especially the stuff on volume. You might need some clarification on that, and here on temperature as well. The difference between Kelvin and Celsius, how those scales look, and the conversions of those. Okay? So that's it. So have a good one.